What's up guys? It's Sais here.
Hello guys, it's me again, Leo Berenilla.
I am Russell Carlo Rente from STEM Goes.
So hello guys, Sadkal Baka here from Club STEM Goes.
Hi, I'm Arnold Damagan from STEM.
What's up everybody? This is me, your boy Pete John Regiluay.
So hello guys, I'm John Martin Vibertos, grade 12 STEM Goes.
I am Cyrus San Juan of STEM 12 Goes.
Welcome to my house. And today, I will going to make a video. So come on, join me.
On average, the Philippines experiences 20 storms and typhoons per year, not including heavy rains caused by southwesterly winds. It shows how vulnerable our dams are to overflowing, which causes major floods, particularly near the reservoir. The goal of this study is to determine how capable Arduinos can give a warning to the people living nearby dams and raising the level of awareness.
The importance and benefits of our research or our project. So, the importance of our research is to help our economy and help the place have dams in the Philippines. Also, the benefits of our project is the best in place to maximize the place in spite, and this project helps the people to avert disaster.
Ang opinion ko dun is makakatulong talaga yun na maigi sa mga residente na malapit dun sa mga dam. Kasi isipin natin, yung bot na yun is for safety ng tao and it's manual and automated. So, hindi na siya katulad ng dati na ginagawa ng manual checking. It's automatic. So, mas mapapadali yung trabaho ng tao and mas calibrated siya para sa ganong gawain.
Why is our research important? So, because Arduino nowadays is very commonly used in everyday application. Kumbaga, using Arduino, makakagawa tayo ng mga advanced warning or signal, lalong-lalo na sa mga sakuna ngayon nowadays. Tsaka, kumbaga, kulang kasi tayo ng mga advanced materials, lalong-lalo na yung mga warnings. So, mas makakatulong ito para yung mga mamamayan natin na prone sa mga sakuna ay magkakaroon sila ng awareness, tulong ng aming research.
Alright, in today's video, I will going to explain to you guys what is an Arduino, how it works, and what is the importance of it. So come on, let's start. So, what is an Arduino? Arduino is open source, both in its software and hardware specification, so that hobbyists can assemble the simplest Arduino modules themselves by hand. More sophisticated pre-assembled Arduino modules can be purchased and are modestly priced, so they are not expensive. The hardware comes in many format specifications, from a small wearable device to larger surface-mounted modules. The primary mode of computer connection is via USB through Bluetooth, serial, and Ethernet form factors also exist. So how do we apply Arduino? Arduino allows us users to have a simple pathway to create interactive objects that can take input from switches and sensors and control physical outputs like lights, motor, or actuators, because the language is based on well-used frameworks. Arduino can also interact with other software on the computer like Flash or even Twitter or Instagram. Alright, I've watched a cool video on how do we apply the Arduino. Just take a look into it.
Science, the home of creativity.
Did you see that, guys? So, why is it important? Arduino is important because it is used in many everyday applications. Many children and adults don't realize that the Arduino is behind many things that are used daily. Businesses that use Square, a device that can be plugged into smartphones to accept payments with credit cards, may not realize that it is made possible by Arduino.
So our research local is the Arduino warning bot, and the area that we specifically use this warning bot is the dams, where the dams is. We built this bot to have automatic warning features that other Philippine dams don't have. Many dams right now use manual water leveling to provide safeness, but this research aims for the safety of the citizens that are near the dams by giving them warnings. As the research goes on, automatic dam warning, but powered by Arduino results can be more exact in terms of water leveling, and it can have more capabilities through future revisions and upgrades. To test the validity of the project, we will build a prototype mini dam that can test the potential of our project. Furthermore, we will characterize this method of giving warning through SMS by GSM modules that are connected to the Arduino Mega that we program. This project best implies to maximize the place in pipe, and this project helps people to avert disasters.
Today guys, I'll discuss our data gathering method. First, the researchers will first perform tests to assess the accuracy of the water sensor by evaluating how similar the sensor's measurement is to the real water measurement. Second, the researchers want to know how many phone numbers can be saved in the Arduino directory. Third, the researchers will calculate this by using 30 mobile numbers as a comparison test and counting how many of the 30 phones received the notification. Lastly, the researchers will calculate the water level sensing time and the sending time as the final variable. This is our data gathering method. Now, let us proceed to our data processing method. After gathering all the data needed in the study, the researchers proceeded to the data processing. The researcher's step-by-step method is as follows. First, calculating the water sensor accuracy. Second, putting the 5 results in the table and getting the mean. Third, comparing the actual water measurement to the sensor's water reading, 100 ml to 500. Fourth, getting the total mobile number that receives the notification. Fifth, measuring the water sensing time and sending time. And last, tallying the mean of the 5 trials of the water sensing time and sending time.
Now we're still talking about the independent t-test. I'm going to explain to you the formula, but let me define to you the given first. The x1 is a sample mean 1, the x2 is a sample mean 2, the sp2 is the pooled variance, n1 is the sample size 1, n2 is the sample size 2, ss1 is the sample squared 1, ss2 is the sample squared 2, and lastly, df is the degrees of freedom. To find the t, we're gonna have to put the sample 1 minus sample mean 2 over the square root of pooled variance over sample size 1 plus pooled variance over sample size 2. And now to find the pooled variance, you're gonna have to add the sample size 1 plus sample size 2 over the degrees of freedom 1 and the degrees of freedom 2. And that's pretty much it. I'm not really into math, I'm not good at math, but I hope that I explained to you the formula.
So what's up, Arduino buddies? I'm your buddies in 7 materials that we use in our research. Let's go! So I will introduce to you the 7 materials that we use in our research. This is water sensor, Arduino, GSM module, breadboard, male wires, female wires, and lastly, female to male wires. So here we go. I'll discuss to you 7 materials. So the first one is water sensor. Water sensor brick is designed for water detection which can be widely used in sensing rainfall, water level, and even liquid leakage. Connecting a water sensor to Arduino is a great way to detect a leak, spill, flood, rain, and etc. It can be used to detect the presence, the level, the volume, and or the absence of water. While this could be used to remind you to water your plants, there is a better groove sensor for that. The sensor has an array of exposed traces, which read low when the water is detected. So the second one is Arduino. Arduino board is designed to use a variety of microprocessors and controllers. The boards are equipped with sets of digital and analog input and output pins that may be interfaced to various expansion boards, shields, or breadboards prototyping, and other circuits. The boards feature serial communication interfaces including Universal Serial Bus or USB on some models, which are also used for loading programs. So that's it. So the third one is GSM module. A GSM module is basically a GSM modem like SIM 900 connected to a PCB with different types of output taken from the board, CTTL output for Arduino 8051 and other microcontrollers, and RS232 output to interface directly with a PC or personal computer. The board will also have pins or for provision to attach mic and speaker to take out plus 5 volts or other values of power and ground connections. This type of provisions vary with different modules. The fourth one is a breadboard. A breadboard is a rectangular plastic board with a bunch of tiny holes in it. These holes let you easily insert electronic components to prototype, meaning to build and test an early version of an electronic circuit, like this one with a battery, switch, resistor, and an LED or light emitting diode.
Male wires. Male ends have a pin protruding and can be plugged into things, while female ends do not and are used to plug things into. Male-to-male jumper wires are the most common and what you likely will use most often. When you're connecting two ports on a breadboard, a male-to-male wire is what you will need. Female wire or female connector. A female connector is a connector attached to a wire, cable, or a piece of hardware, having one or more recessed holes with electrical terminals inside, and constructed in such a way that a plug with exposed conductors cannot be inserted snugly into it to ensure a reliable physical and electrical connection. A female connector is also known as jack, outlet, or receptacle. This type of connector can be recognized by the fact that when it is disconnected or removed, the electrical conductors are not directly exposed and therefore are not likely to make accidental contact with external objects or conductor. The difference between male and female connector is simple. Just like the people, the male has a sticking out pin which he plugs into something. The female, on the other hand, have a hole in which he receives something, and it is usually the pin of the male connector.
So this is how we connect our Arduino in breadboard. We connect water sensor to breadboard. The breadboard or protoboard is construction based for prototyping of electrons. We use breadboard to sort the wirings, then connect in Arduino. Same with GSM, which is already attached in breadboard. Then connect in Arduino. So this is what it looks like.
Wow! That was great video for today. I hope you guys enjoy and learn some new things for today. But once again, I am Siren of Arduino Daddies. Don't forget to click and subscribe our YouTube channel for more upcoming videos. Goodbye, sayonara.